In this lesson, we are going to talk about post-processing. Yeah, I know, again, but this time with React 3 Fiber. I think you're going to love this one. It's not an easy lesson. You will see why. We are going to dive into really complicated stuff, although it's actually the base of post-processing that we're going to see is quite easy, but I'm going to show you some more advanced features. And yeah, I really think you're gonna love this one. So stick to this one. It might change the way your experiences look so much. So yeah, post-processing also benefits from the React and React 3 Fiber systems. You know, we can do more stuff, share more stuff, use helper, and just by adding one helper and a few attributes, we have something happening on the screen. So that's great. It got easier to implement and also optimized. Optimized? How? You will see why. In this lesson, we are going to learn how it differs from the post-processing technique we've covered before. All right, it's not exactly the same thing. It's really not the same thing that we did earlier. It's still post-processing, but in very different manner. And it's not just about the syntax with JSX. We are going to implement a bunch of effects just to provide you some examples. And at the end, we're going to create our own effect so that you can also create your own post-processing effects for your applications. By the way, before we start, I have to warn you about something that you might have experienced when using the starter. When you run npm install, you might receive an error about dependencies not being able to resolve. It's not always the case. I have trouble pinpointing exactly the conditions to have this error, but when you do npm install to run the project, you might get an error. And if you don't get the error right now, you might get that error later. All right, so if you try to install the dependencies or one specific dependency that we'll add later in the lesson, you might get an error. I will show you in the lesson the exact moment, but maybe you got it right now when you try to install it, or if you're using the final versions of the project. To fix that, you just need to ignore that error by adding a dash force at the end of the npm install. So it's going to look like npm install dash force. And if you want to install the library, it's going to be npm install the library, the dependency dash force. All right, it's because one of the dependency we are using is using an old version of another dependency, and there are some conflict in checking if they are compatible. All right, it doesn't mean they are not compatible. It means that Node.js, maybe more npm, can't check if it's working. We just say just force install it and it's fine. Okay, so why are we using another solution? The issue with post-processing. In the previous lessons, we used post-processing, with the effect composer, and we added passes. Remember, we added one pass and another pass. So the first one was the render pass, and then on top of that, we added another pass and another pass and another pass, and it looked great. Each pass had its own code and was completing one or multiple renders. Okay, so you add one pass and the whole screen is being re-rendered to apply something. And then you add one more path and the whole screen, the whole canvas is being re-rendered. And it will keep doing that like this. Those passes all occurred independently, and some of them were doing the same renders. Like if you, apply some outline effects, things like that, you have the depth render, normal renders, etc. And it created the performances issues. And we might think, well, there is no choice. Each pass is doing its own stuff. After 5 or 6 passes, the performances were dropping. Especially if you have a big screen and also if you have a high pixel ratio. All right, the DPR thing on MacBook Pros, an example, we have usually a DPR of 2, meaning that we have a density of pixels of 2, meaning we have 4 times more pixels to render, and the dependencies can drop quite fast. All right, on the phones too, you have a high DPR, and it's a weaker device, and we have more pixels to render. What the hell? And we have some issue. So if there is a way to optimize that, we should use that solution. If you have just one pass and your scene is not too complex, it's fine, but we are going to see some optimizations by using the new solution, and that new solution is named post-processing. Yeah, the name is post-processing, which is not convenient because we are talking about the post-processing in general, and the name of the dependency is post-processing. Anyway, the name of it is post-processing. I put a lot of link with that lesson. You can check those, and that's this solution. All right, for now, it has nothing to do with React 3 Fiber. It's only a 3GS thing. The name is post-processing. The various passes you know, the passes we used to talk in the previous post-processing lesson, will be merged into the least number of passes, meaning that maybe you can add like, I don't know, 3, 4 passes. So 4 passes on top of the render, and at the end you will only get 1 pass, because those will be merged together in some ways that we will discover together. By the way, since those passes are converted into less passes, maybe just 1 pass, we don't talk about passes anymore, we talk about effect. We're going to add a bunch of effects from now, and those will be converted in as less passes as possible on its own by using the specific syntax you will see. So yeah, the effects will be merged together into 1 or multiple passes if needed. Maybe there will be multiple passes actually, you know, if you use very specific effect, and that effect might do multiple passes because there is no choice. But if possible, those passes will be merged into only 1 pass. And it will also keep the order that we in which we added those effects. So we can decide to add, I don't know, some color management, and then some outline, and then some vignette effect, and then some bloom, and those will be added in that order. By the way, we can also choose the blending for each effect, and we're going to talk about that a bit later. What's the blending exactly? It's like in Photoshop. You know the blending in Photoshop? If you don't know it, don't worry, I'm going to explain that in details. So obviously, React Fiber implements it, because this is a React Fiber chapter, and the name is React 3 post-processing. So it's part of the React 3 scope, as always, just like some other dependencies that we have been using, like Fiber. Fiber is part of React 3, and we're going to use the post-processing one. About the setup, so I have the setup running right here. I'm not going to show you the final result in this lesson, because I'm keeping some surprise. You will see along the way when we add the various effects. All right, it's not passes anymore, it's effects. So yeah, I was talking about the setup. Classic setup, we have a sphere, a cube, a green floor, we have a light. I didn't activate the shadows because we don't really care about that. I've added perf so that we keep an eye on performances. Keep an eye on performances on your screen too, because mine is it's quite a small resolution, and the canvas is only 1/4 of that resolution. Post-processing is still heavy on the GPU and even the CPU, so you might experience some frame rate drop. Just keep an eye on the performances, and you can use the perf here. I added Dray to the dependencies so that we can use orbit controls and rotate around. Nothing different than some of the previous lessons. So how do we implement that post-processing thing in React 3 Fiber? We are going to need 2 dependencies. Obviously, we're going to start with the React 3 post-processing and also the post-processing. But for now, we are only going to add this one. And this one will also add this one automatically, okay? If you want to use post-processing in React 3 Fiber, you just use this one. Then why do we need this one? Well, because at some point we are going to need to pick some very specific information from the post-processing native dependency, and we're going to install it. You will see why a bit later. So just for now, we need this one here. Let's go. We're going to add it to the project. So I'm going to open a new terminal in the same folder and run npm install like this, React 3 post-processing, and as always we are forcing a very specific version. It's going to be the 2.6. all right, try to use the same version as me if you want to get the same result any later for your own project. You can have fun and update the dependency. You might see some differences. So it's the 2.6, and I'm going to do it. I think this one it will install properly. If you get an error and you are sure that you wrote it perfectly, you might need to add the force. All right, dash force at the end. Check the error. If it's something about npm can't check the compatibility of those 2 libraries or something like that, just add the dash force at the end. But for me, it worked nice for now. You will see later that at some point it won't work that well. All right, I've added the dependency. I'm going to close this terminal here, and I can hide this terminal. In experience.js, we're going to import Effect Composer from React 3 post-processing. Effect Composer, just like the Effect Composer that we used before? No, it's not the same, okay? It's named Effect Composer because it will compose some effect, Makes sense? But it's not the same class as the one we use in the previous lesson. So React 3 post-processing right here. Okay, great. So the name is also Effect Composer, but it's not the same Effect Composer. And this one can be used just by adding a tag in our JSX. Great. So it means we can still do just tags. It's tag-based composition, and we should see the effect, and you will see that it's going to work. So the basic usage of it is just adding this like that. Okay, we are going to add some effects in there. By the way, adding everything in experience.js because we won't have too much code, but one good practice is to put everything inside a different component. Developers like to call it effects, just effects. Like you create your own component, you name it effects, and you put the effect composer and the various effects that we are going to add. But we don't have that much code in this lesson, so it's going to be fine. Yeah, by the way, we don't need to add the first render. Remember from the post-processing, the previous post-processing lesson, first we need to do a classic render and then add passes on top of that render. Right here, it's not, we don't need to do that. We can just start adding effects. By the way, during this whole lesson, you might need to reload. All right, because it's doing some heavy changes with the renderer, etc. And if you see something odd, just give it a reload. I think I'm going to reload every time just in case. It's a reflex, so make sure that you're reloading just in case. The only attributes we're going to see on the effect composer is about the multi-sampling. Okay, multi-sampling, if you remember, is used to prevent the aliasing effect. We talked about this one. Well, actually, I think it was on the post-processing lesson. The default value is 8. So if you don't remember, the aliasing, you know, it's that stare effect that you see, I don't know, like in old video games, or if you deactivate it on the WebGL. If you deactivate it, you know, on the WebGL renderer, you set anti-alias true if you don't want to see those stairs effect on the geometries. If you want, yeah, and if you're okay to see those, you put the anti-alias to false. That's the same idea here. The anti-alias is named multi-sampling. That's the one that it's being used natively in the WebGL 2. And we can actually deactivate it. And I think if we add multi-sampling and we set it to 0, and you reload the page, see I had to reload the page. I'm not sure you will see the difference on my video on my screen because of the video compression. So check on your computer, and here see those stairs, ugly stairs on top of the cube. That's what we are trying to avoid. So the default one is 8. You can have a in-between value, like if you put 4, it's going to look okay. Give it a reload every time, but 8 is the default one. I'm fine with this one. I just wanted to talk about this attribute quickly, and we won't change anything else on the effect composer. There are other attributes, but we are not going to cover them here. And I'm good with the default one, so I'm going to remove it. All right, next, we want to have fun and add some effects. So how do we find effects and how to implement them? I mean, where to find the effects and how to implement them. We're going to test a bunch of effects, not all of them because it would be a bit boring, just some of them so that we cover some issues that you can have, and I can show you some cool stuff too, because there are 1 or 2 effects that I really want to show you. They're so cool, you will see. Still, you should, yeah, as always, we're going to see some of them together, but you should roam the documentation. I'm going to provide the links to those documentation, just so that you discover most of them. You know that they exist. If you want to give them a try, you can give them a try right now, or maybe wait for the end of the lesson. The goal is just to know that they exist in case you need them. At some point, you'll be like, my experience doesn't look that great, and you will remember, oh, there is, I think, an effect that can add a lot to the experience because you saw it in the documentation. So give it a go, check the documentation. Yeah, by the way, those documentation are spread across React post-processing and post-processing, okay? It's a kind of an issue because you need to check both of them to refine the various attributes, etc. It's a bit messy to have to check them, to check 2 of them, also because there is a lot of pages and the formats are different. But anyway, you just check them and then you should find a bunch of great information. So I put some links. As always, check the tab links. So for post-processing, I'm not talking about React Free Fiber, I'm talking about post-processing. There is the repository right here, okay? So check that, you get some examples, and you get a bunch of included effects. Those are the effects provided with the dependency. There is the documentation, which is generated automatically from the code. All right, it's this documentation takes the code and check the various commands, and they wrote the commands in a very specific manner, making this documentation automatically. So that's great. If you want to check the bloom effect, you see everything in there, so it can be useful, but that's a lot of information. There is a demo page. Now would be a good time if you want to pause the video and have some fun. They have great examples. Check that, it's looking great. This one is about SMAA, so it's something about the anti-aliasing without using the default one from WebGL. There is one about bloom. I'm not going to spend too much time on this one, you will see why. There's one about blur, you can blur everything. Color depth, what do we have? We have some outline thing. Yeah, okay, to have an outline around your geometries. Some God ray, nice, looking really cool, etc, etc, etc. I let you check those on your own. So those were links for the post-processing, and those are the links for the React post-processing. So there is the repository as always. This one is on GitHub too. A bit more example in the README. I mean, a bit more content in the README. There are some demos too that we are going to check quickly, and how to implement it. That's what we are going to do together. The list of effects implemented from post-processing to React. Okay. Oh no, that's not the right link. Let me check. API, custom effect. Oh yeah, no, it's a page with both things. We're going to talk about that, like custom effects. We're going to talk about that together. But if you scroll a little, you see how to implement those effects. So the one native to post-processing inside React 3 post-processing. It's a bit hard to follow all those names, but anyway, if you want to check how to add the sepia, here's an example, and we're going to do a bunch of them together. And there is also a more user-friendly versions, which is automatically generated, but it looks better. You have some good content, color, syntax coloration, etc. So it's a bit better. This one is kind of the mobile version, but yeah, check that. If you want to see how to implement the glitch effect, you get this. If you want to see how to implement, I don't know, some grid stuff, you get this. I think there is an error with this. This was supposed to work. Maybe if I open it. Yeah, the screenshot is probably created automatically. Yeah, see. But the render, the Suzanne, which is the name of the monkey here, is not available here. That's a bug. And you get the parameters, etc. This one looks really good. The point menders are using this template to create their documentation. It looks really good. All right, let's close this. Let's close that and that and that. And we get back to the layout we had. And we can start. So sorry it took quite some time to talk about those, but now we can add some effect. And we are going to start with the vignette, which is a bit weird in French because vignette we don't think about vignette as this kind of thing. But anyway, vignette will make the corners of the render. So I'm talking about those corners here, darker. That's just a cool effect that will, in movies and things like that, especially if you're trying to create kind of a dark mood for a horror game or horror movie, you make the outside of the render a bit darker. You will see when we implement it, which is going to go super fast. We import vignette. I don't know how you say in English, vignette? We say vignette in French. You import vignette from React 3 post-processing, and you just add it to the effect composer, and you can auto-close it. And it's working. I'm talking about this dark area here. If I remove it, see, it's not there anymore. If I added it, it's there. There is an issue. We can't see it there and there, but we're going to fix that together. So first, those can be controlled using attributes. Super handy, as always. I'm going to put some random value. Darkness equal, I mean, not random. I've tested them and see it's a bit too strong actually. And it's working. And there is a bunch of attributes and I will let you check them. I'm just showing you like kind of the useful default attributes. I said earlier that we can control the blending. What was I talking about when I said blending? The blend function is an attribute available on all effects. All right, we're going to test it on the vignette, later on another effect, and we can change the blending. But what's the blending? The blending, it's like in image editing software. I will take Photoshop as an example, but most 2D softwares, editing software, have this feature. It's when you draw a layer on top of another layer, you can choose how this top layer will draw on top of this one. It can be like multiply, lighten, average, or whatever. Those names are so weird. We don't know what you get from that name, but I don't know, they found some random name to try to explain what the blending should do, and we can control that, meaning that this effect, so the vignette effect, will be drawn on top of the previous pixels in a very specific manner. And that's what we are going to do. The default one is normal, meaning that the pixels are just being drawn on top of it, and there is also alpha support. By that I mean that the vignette effect is not drawing on top of everything and we can't see the previous render anymore. The vignette will draw this color, and using the alpha, where we will still be able to, the alpha channel inside that effect, we will still be able to see the base render behind. Okay, and that's the default blending. If you're happy with this one, you can just keep this one, but we are going to discover that we can change it. To change it, we first need to get the list of the blending, and that's where things get a bit complicated. Because we added React 3 post-processing to the project, we can already import things from post-processing directly. Okay, so we need to get those blending lists, this blending list from post-processing. And since we added to the project, and I can show you, don't have to do it, but I can show you from the package.json. Since we added this library here, it's like we already have the post-processing library to the dependency. All right, that means that we can do, let me show you, you can do this one with me. So I'm going to close that. We're going to do import blend function from post-processing like this, and check that. You can log it to start with. Do that with me. We get access to those blending. It's an object with a bunch of properties inside. That's all. So we get access of it. You can do that. It's okay. But you should not do that, because you are relying on a dependency inside another dependency. If React 3 post-processing changes, you might get some issues. Maybe they change the version or whatever. It doesn't make sense. If another developer arrives on the project, he will check your code and see, okay, post-processing. And then he will check what's post-processing, and he will check there, and there is no post-processing. So what the hell is that? It's okay, especially if you work alone on that project, but I will show you the right way of using it, which will create a bigger issue, but that way I can show you that bigger issue too. So that we are just for the sake of learning, as always. So let's go. We are going to add post-processing on our own, so ourselves, to the project. I'm going to open the terminal again. I'm going to create a new terminal in the same folder, and we're going to do npm install post-processing and use a very specific version, which is a 6.28. I don't think they are updating this library a lot these days, but let's use my version just in case. And I'm going to install, and we might get an error. See that? You might get an error too. Let me show you the beginning of the error. It's something so that you remember this kind of error. Unable to resolve dependency tree. It's something about Three.js. All right, Three.js version 0.145 can't resolve whatever with the post-processing. I don't know what's happening. Maybe something didn't do his job. I'm not sure. It's not a big deal. It's just that those can be checked, resolved to make sure that they work together. We don't care about that. We know what we are doing. We are going to force it. And to force it, all you need to do is npm install post-processing, exactly the same. So it's the same command, and add -force at the end, like that. Be careful with white spaces. It's -force in they are together without spaces between the dash and force. And you just press enter and check that it's going to install. Yes, there are some vulnerabilities issues because we're forcing the version. Just ignore the vulnerabilities, all right? Okay, great. I'm going to close this terminal and hide that terminal here. And I'm going to give it a reload, and it's working. And now we get those from post-processing that we added ourselves to the project. And you can see it right here. It just makes more sense. That's all. Okay, cool. Next, finding the right one is hard, but with a debug UI, it's much easier and you can go through all of them with just a few clicks. I'm talking about finding the right blending function, right? Remember, we just want to add the blending function to the vignette. Finding the right blending is a bit hard because see those? There are too many of them. That's where you usually add some debug UI like Leva. Okay, you can do it. We're not going to do it because it will take a bit more time. I'm going to provide you some that will look great with the vignette. Later, we're going to add Leva. Okay, we just don't do it every time because the lesson would take too long and be too boring. But if you want to add Leva right now and add use controls, you know, to add some tweaks and test the blending, be my guest. We're going instead to just force one, so blend function on the vignette, and we're going to use the blend function object that we retrieve from post-processing and use the color burn just as an example. It's a bit too much, but at least we can clearly see the difference. Check that. It looks like that. It's really bad. Maybe that's the effect you wanted to go for with, but it looks really bad. Okay, I just wanted to show you that this is changing how the vignette is being drawn on top of the initial, the previous effect, which for us it's just the render. If you want to use the default, you can put just normal, and we get the default one. Yeah, that's all. We are going to see more examples about blend functions later in the lesson. There is a bug. Maybe you've noticed it, but the vignette effect doesn't work here and in there behind the perf. All right, if you comment the perf, check that. You don't have to do it, but I can show you just on my screen. Vignette is working here and here, but not here and here. And it's something with the background. And if you remember, we already covered that 2 or 3 times. This background here is actually transparent. So it makes sense. That's actually a good thing. The vignette is not being drawn here because this is transparent and maybe you want to see what's behind the canvas right here. But it's not the case for us, so we need to fix that. And to fix that, it's easy. We just add a color to the scene, to the background of the scene. You know how to do that. We add a color in there. We set the color. I'm going to set the color to white. Later, we're going to put something darker so that it looks good. But for now, let's keep the white that we have right here. So it's now white, just the same as it should be the same white as this. And then we attach this color to the background property of the parent, and the parent is the scene. So it's like doing scene dot background equal an instance of color, and we set the color to white. And we get that. I know the sphere keeps disappearing. I don't know why. So give it a reload. And now the vignette is working all around and it makes more sense. I think it looks better. It depends on what you want to create anyway. That's all for the color. Quite easy. I'm in the background. Next is the glitch effect. So let's go. We've discovered the vignette effect. Let's try the glitch effect. And it's kind of the same that we had in the first post-processing lesson. It's kind of the same idea. The glitch effect will make the screen glitch, all right, randomly, like in hack scenes in movies when the good guys are being hacked by the bad guys. All their screens are doing, and then the bad guy's face appears on the screen. Silly hack scene in bad movies anyway. Yeah, I have to warn you, be careful with the following content if you're sensitive to flashes and fast movements. It's not too much, but I just want to warn you, maybe lower the brightness of your screen if you're sensitive to those, and make the screen smaller to make sure that you can handle those flashes. So let's go. We are going to import a glitch from React 3 post-processing, and just like we added the vignette, but this time we're going, let's test them separately. So I'm going to comment the vignette and add the glitch so that we focus only on one effect. You can have fun if you want to combine them, but I'm going to focus on the glitch effect. Give it a reload, and then it's working. And it's a bit random by default. We can control that, but see, we have to wait maybe 1, 2, 3, 4 seconds and let's go. And sometimes it's faster, sometimes it's smaller. Anyway, the default one is working great. And I told you that you can test both if you're curious. Check that. I have the vignette and the glitch. Perfect timing. And you can invert them if you want. It's up to you. We're going to focus only, for now, we are going to focus only on one effect at a time. So obviously this glitch has some available attributes. We're going to do delay equal, and check that for the delay we provide two values in an array. The first value is going to be 0.5 and the second value is going to be 1. And check that is going to vary between 0.5 and 1. Maybe it's in between 0.5 and 1.5 since it add this one. No, I'm not sure. I think it's between 0.5 and 1. So this one is a bit more, the frequency is a bit higher. Then we can set the duration. It works the same, like when the glitch starts, how long you want it to stay. 0.1, 0.3, it's going to be quite fast. Let's go and check that. It's some really quick glitches. And we can control the strength of it. I wonder how the shader of this one looks, because doing this glitch effects is really funny in shaders. I mean, depends on your definition of funny, but I know that I did some custom shaders like this, and I had fun doing those. Okay, and yeah, the strength of the effect will vary between 0.2 and 0.4. I don't know what exactly are those values. Maybe if we set it smaller, I think it's how much it offsets. Maybe it's how much it spreads on the screen. I'm not sure exactly, but if you put smaller values, you get a smaller result. I mean, the glitch is a bit more subtle. Okay, I'm going to put back 0.2 and 0.4. Nice. One of those attributes that we haven't seen yet is the mode attribute. But the values are stored in the glitch mode effect, which is available in post-processing. All right, there is a mode. I will show you what the mode attribute does, but we need to retrieve it from the post-processing dependency as the glitch mode. So let's go, glitch mode, sorry. So we can retrieve it right here. It's going to be glitch mode from post-processing, not reactive post-processing. I'm talking about just post-processing. And then we can use it, but first I'm going to log it so that you see what we get in there. We can disable the effect so that the mode is there but doesn't work anymore. We can make it sporadic. We can have a constant mild and constant wild. I'm not sure of the mild. What does that mean in French? I don't know. I mean, I don't know that. Anyway, we're going to test those. It will make sense once we test them. So mode in there, and we're going to use the glitch mode. Constant. Let's test the constant mild actually, and check that. We get this. Okay. If you want it to be sporadic, maybe that's the default one, by the way. Sporadic. Yeah, the sporadic is the default one. And there is also the constant wild, I think. Yeah, it's like all the time, very regular. Okay, and we can disable it if we want using the disable like that. And it's not doing it. Oh, disable is doing it. Disable. Doesn't make sense. I wonder what's happening. Yeah, the disable doesn't seem to be working. Anyway, we don't care. We can put back constant while. I'm good with that. And we are going to comment it anyway right after. Next one is the noise effect. The noise is not, I'm not talking about noise that you can hear. The noise will add some parasites to the screen, you know, like in old movies, or when, do I have an example? Yeah, when you're trying to film some radioactive place, and the camera gets closer to the radioactive thing, and then it starts to you start to see some parasites. Anyway, those are my best examples. So let's go. You're going to see what I mean by that. First, we're going to import it. So from React 3 post-processing, noise, like that. We're going to comment the glitch finally, because this one is bothering me a bit. And we're going to add the noise like this. And it looks like that. A bit too much at first, but we are going to tweak it as always. No. Okay. The default result doesn't look really appealing, but we're, with the right tweaking, we can achieve a better result. First, the noise, we should add a blending function on this one. So we add blend function so that the noise merge differently on top of the what's being rendered already. We add the blend function I thought we had the blend function. Where's my blend function? Yeah, it's here. I don't know why VS Code doesn't want to complete it. And we can change the blending, and we're going to start with soft light. And you will see what we get. It's better. All right. Before we had this. With the blend function soft light, we get this. The effect does the same thing, but the way it's being drawn on top of what has already been drawn is different. And it's going to use that algorithm that I can't explain. I have no idea what's inside there, which is named soft light. That you can find actually this one, I think, on Photoshop or whatever 2D software. Maybe it's lighten. I don't know. Anyway, and it looks a bit better, and it's closer to the initial render we had. I've put some. I use those sometimes. It really depends on your scene, the effect you want to go with, how dark your scene is. But you should try those. I like the overlay. This one is kind of the default one that we use a lot, but it's a bit too strong. There is the screen that works pretty well too. But in the case of this bright scene, not that good. But for a dark scene, I think it's much better. There is the soft light that we just used, and there is the average that we look fine to. Yeah, check that. It's a bit too gray actually, but if you don't have a tone mapping, maybe it's better. Anyway, I will get back to the soft light because I know this one looks good with that scene. And as always, to test those, maybe you should just add leva and the blending function to leva, which should be quite easy. Yeah, also another attribute that might help you get the best result is pre-multiplied. So pre-multiplied, you just add it, you don't have to set it to true. So now it looks like that. It's a bit different. The idea is that pre-multiply will multiply the nose with the input color before applying the blending. It will make it look different also depending on how dark and bright the area is being, the noise is being applied on, meaning that this part will actually, you can't see much of a noise on this part here, but you can see it more clearly on this part. So I don't know, it looks a bit different. You have to test it. And if you test the other one that we used before, maybe you will get a different result too. So if I use screen, check that. Yeah, this one looks now a bit better. Maybe the average, let's see what we get with the average. Yeah, okay, why not? That depends on what you want to build. I think that adding the pre-multiplied makes it look better. So first add the pre-multiply and then play with the blend function. Okay, next, you're gonna love this one. That's my favorite one. I want to add it all the time. I want to add too much of this effect every time. So I'm going to show you the bloom effect. The bloom will make our scene glow. Suspense. Since we are going to make our object glow, it will be much better to test with a darker background. Yeah, by the way, if, I don't know, that cube, we're going to test on that cube is glowing and everything is already too bright, it's not going to make it's not going to look very good. So first we're going to put a dark background like this. Okay. Next, we are going to import that bloom effect. So bloom like that. And we are going to add it as always. So we comment the noise and we add it right here like that. And at first, no big difference. Actually, you can comment it. Maybe there is a small changes in the light. Maybe you can notice something, but nothing very interesting. So we need to tweak it, but you're going to love it. It's working, but the default configuration of bloom makes objects glow only when their color channels go beyond 1. Actually, I think I did a mistake here. I think it's 0.9. Anyway, for now, we have an issue. We have a scene with colors, and I just said that we need the colors channel, so RGB, to go beyond 1. So what the hell? That makes no sense. I mean, if you put a red cube, it's going to be 100. RGB 100. If it's blue, it's going to be 001. How do we make the color channel go beyond 1? Well, we're going to fix that. There are multiple solutions, but first we must fix a limitation that we have right now in the scene. It's that we have a tone mapping. Remember, React 3 Fiber by default sets a tone mapping, which will tweak the color to make it look like HDR to LDR, and it looks good, but the tone mapping will clamp the colors to between 0 and 1. For now, our colors are clamped between 0 and 1 anyway, but if I show you the next step and make the colors go beyond those values, well, the tone mapping will make sure that it goes back to the range 0 to 1. So first we need to deactivate the tone mapping, but we don't want to deactivate the tone mapping on the whole experience. We just want to deactivate it on the object that is going to glow. And we can do that by adding tone map false on the concerned object. So it's this one. Is going to be there. So it's the second mesh. And in the material of the second mesh, which is the cube, we're going to test the bloom on the cube. We're going to add tone mapped equal, and we send it false. Come on, like that. So the color changed. All right, I put back true. Check that. It's a bit more gray. And I put false, and it's less gray. Okay, we don't care because we're going to make that cube glow like if it was a pure light. Okay. Instead of using that, next, now that this cube and its material are not, the color is not clamped between the 0 to 1 range, we want to provide different values. But how do we do that? If you provide a value like this, medium purple, red, salmon, or whatever, those values are values that will be some hexadecimal. Anyway, it's traditional colors, and it's going to be a RGB that goes from 0 to 1. So those, we can't go beyond 1. But since color will be used as a 3JS class, if you check the documentation of the color, I'm not sure I have it there. No, I don't have it there, but check on the 3JS documentation. There are other ways to provide a color. So you can do maybe something like that, okay? Like this. Okay, we get a different color, and as you can see, we have already something happening. You can do something like RGB and like that. Okay, that's great, but those are still kind of limited, and we won't see much of a brightness. We can see it because the threshold is 0.9, but we can't really control it. I'm going to show you a way to really go beyond those, and actually it's written right here below. Instead of providing a string like this, we're going to inject an array. And those are the RGB channels, and we're going to provide R to 1.5, not 1, 1.5, the B to 1, and the green to 1, so the G to 1, and the blue to 4. So this one is quite beyond the limit. So this cube should be super bright. Be careful, you're going to be a bit disappointed, although it's going to work. So let's give it a try. We save, and it seems to be working. Not the surprise we were expecting, don't worry, it's coming soon, but it's working, all right? It's much brighter, and since this part here, like where my cursor is right now, is the RGB is much beyond the 1 range, well, it starts to glow. So it's working, great. I'm going to remove the console log. This one is messing up with my console. All right, so we were right here. Okay, so if I put less, I don't know, on this one too, okay, it's a bit different. If I put just 1, okay, it looks kind of orange because it's creating some kind of red light. Maybe if I put 5, okay, this one is really red right now. It seems to be working, but it doesn't look that great. So I'm going to put back 1.5, 1, and 4. And let's see how we can improve that. First of all, what's not working in there? Try to compare that to real life. If I put like a light, like, I don't know, like a bulb light right here, and I increase the power of that light a lot, it will start to shine, especially if it's filmed by a camera for a movie or whatever. This light will start to shine, and it will create a glow. And that glow is not just, let's say that's the light. It's not just around, close to the light. The brighter it is, the bigger the glow. Just like if you look at the sun, it will be like a huge glow that's blinding you. That's the idea, and we want that result. And it's going to be super difficult. Check that. To the bloom, we need to use Meep, Map, Blur, and we are done. It's working. So that was a joke. Obviously, it's super easy, but check the result. Check how good this is working right now. We get like a AAA game glow right here. That's actually the technique that is used in most games because it works beautifully. And in terms of performances, it quite some work. Okay, there is something happening with the meat mapping that I'm going to quickly explain, but the performances are really good anyway, and I think it's worth the cost of performances. Actually, you can check your performance here. It's almost the same. It's so good. This one is so good. Yeah, so that was super easy. We just added the map blur. I recommend you to add the map blur. Remember how it was before? It looks like that. Map blur, it looks like this. Nice. The map blur, we use the same map mapping technique that we talk about when we talk about textures. It's when you start from your original texture. In our case, it's that render, and you create a smaller version. It's usually half small. And then you create a smaller version. And then you create a smaller version, and then you create a smaller version until you get something super small, like 1 pixel. Actually, I think they stop a bit before the 1 pixel map mapping, because there is no use of doing that. And this is done by a bunch of technique, GPU technique, etc. Some ping pong thing with the render targets. Okay, we don't care. It's handled by post-processing. Great. And then those bitmaps, so the version smaller, where you get the pixels that are being merged together into a small resolution, they are then being used to be like they go down in the version, and then they use them up by combining them, and you get this kind of glow that can go super far. Check on your computer, but this part has some glow from this, because this one is really bright. There is the cube is bright, but there is also the light that makes it even brighter. So you can see the glow right here. And it depends on how powerful this object is. I mean, if I reduce this one here, so now it's less, and right here we can't see the glow because it's too far from it. And you can play with whatever value you want. You can make like super bright, like red like this. It's a bit too much. Okay, I think this one is really too much. You can make also the blue brighter, the green brighter. Anyway, play with those, put whatever value you want. I think I have some more example, like, yeah, we can test this one. Let's see what we get. Yeah, I really like this one. It's red, and I think this one maybe is a bit orange, something like that. I'm not sure. Let's test. Yeah, it's orange. It looks super cool. Like this one to create like some kind of light or laser or an explosion or whatever. You can do so much with those. That's super cool. You see that I really like this one. Okay. There are other ways to make our material glow, especially because, check that. There is something that I don't really like. Maybe you can't see it clearly on my screen, but this part here is not that bright. This one is super bright, and this one is not that bright. And I think I told you earlier why. It's because, well, we have a light here that is making this face brighter. So the brightness of the object is a combination of the material we put here and the light that is applied on it, because it's a mesh standard material. And that's kind of an issue. Like if I want my object to glow, I don't know, I want a glowing cube. I don't want it that to be brighter on that face because there is a light here. I want it to be more logical, like a uniform color, a uniform glow. So to do that, first we're going to get back to just a classic orange and see how we can fix that. Okay, so this one is orange, looks good, but it's not glowing anymore. First of all, we can add the emissive attribute. It's not going to fix the issue I told you earlier. We're going to fix that later, but it's just a different way to make something glow. We can add emissive, and to start with, I'm going to provide the same color like that. And as you can see right now, I can't put the values like beyond the one threshold, but I'm going to add orange, and the emissive, so it's a classic orange, will add to the initial color. So it's working in a way because the addition of this one and this one makes it go beyond the one threshold. But it's not that bright. How can we make it brighter? When you use the emissive attribute, which is just a property on a mesh standard material, the 3JS class, we can also control the emissive intensity by using the emissive intensity attribute, and we can provide a value, like a number, let's say 2. And now it's brighter. Okay, and if I provide, I don't know, like 10, let's go crazy, it's super bright and it's working. You might think that the center should be white, like imagine that you have let's say, oh yeah, a forging thing. You know, when they forge, they put the metal in the forge, and when it goes out, if it spend too much time on the forge, it's going to be like fully white. Even if it's orange at kind of a low temperature, I mean it's high temperature, but not that high, it's going to be orange. And if you keep heating the metal, it starts to be white. To do that and get that result, what I like to do is just set the color to white like that. Okay, and now it looks like it's shining like crazy. Okay, and if you put a lower value, just 2, it looks good too. So you have to find the perfect value. As always, please use lever if you want to tweak it instead of just trying to find the right values and changing the number. So what I told you earlier about that uniform thing, we can't see much of it, but maybe check on your computer. But see that? This one is super bright. This one is not that bright. If I put 1 here, see, this is clearly white, but this one is not white. I'm not a big fan of that. I would like to have something more uniform, and that the bloom doesn't depend on the lights around the cube. We can do that by switching to a mesh basic material. Okay, switch to a mesh basic material. But there is an issue. As you can see, we get an error because those properties, those attributes here, doesn't exist for a mesh basic material. We don't have an emissive and an emissive intensity, which is a bit sad. Maybe we should add those to 3JS. I don't see why we can't have emissive on a mesh basic material. Yeah, maybe we should add it. So anyway, I'm going to remove those like this, okay? But how do we get so if it's white, well, it's kind of blurry because the threshold to which something starts glowing is 0.9. Okay, so it's a bit blurry. But how do we control it? Well, it's quite easy. We've already seen that if you use a mesh basic material, you can't use emissive, but you can get back to the initial way of setting a color with an array like this, and you simply put the values at a crazy amount that go beyond 1. And you get back the same effect. But this time, since it's a mesh basic material, it doesn't use the lights. Okay, it doesn't care about the lights. It's a uniform color, and your object will glow just the same from every side. And I think it's better. It's also better for performances. You know, a mesh standard material is worse for performances than mesh basic material. So my recommendation is that if you want an object that just glows, use a mesh basic material and put the values beyond 1. And if you want to control it, you can multiply by the same value. It can be from a state or from lever, and you multiply all of them like this. It's gonna be way too much anyway. It's working, and that value here, I put 10, but it can be a variable, a state variable, or whatever that you can tweak. You do what you want. I'm going to get back to this value. Yeah, by the way, you can control the general intensity of the bloom with the intensity on the bloom here. Okay, I'm going to add some line breaks. Why not? Like this. There is a third one that we are going to see right after. So intensity, if I put 0.5, all the blooms in the scene, the intensity is going to be a bit lower. And finally, there is also, there are multiple other attributes, but there is also this one that I want to show you. It's the luminance thresholds. It's the limit at which something will start to glow. And we can put, I don't know, like 0, and now everything is glowing, okay? Even our orange cube is glowing, the floor is glowing, because everything above 0 starts glowing. And it doesn't look, it's a bit too much. What I like to do, well, it depends on a lot of things, the final result you want to get. But what I like to do in some project is to have an intensity very low, like that, a luminance threshold to 0. I'm not kidding, I put it to 0. So there is a small blur happening everywhere, okay? But it's almost, we can almost not notice that there is a blur right here. It just feels good, like colors are merging together. It's not too much. You can tweak it anyway. And then when I want to make something really bloom, I would multiply this by really big values, like that, and like that. And now it's glowing. I like to do that so that everything glows a little, but if I want something to glow super high, I will set it directly on this one here. And if I want it to glow at higher strength, I just put something like that. Okay, it's a glow everywhere, but maybe it's too much. Anyway, please be subtle, not like me. I'm just a big fan of this bloom effect, and I add it everywhere. Okay, we're going to put back the material of the cube to mesh standard material so that we get kind of the default setting, and put back the medium like that. So medium purple. We are done with the bloom. Let's get back to reality with this one here, and we can remove the tone map. Okay, get the mesh standard material like we used to have, and get back to the white background. Be careful with the eyes, your eyes, so bright. Anyway, let's move forward with another one that is super cool, which is a depth of field. The depth of field effect will blur what's closer or further from a set distance. Kind of a fancy sentence. It's just the depth of field effect. You know, when you focus on an object, what's behind is blurred and what's closer is blur, which adds a lot of realism to your scene, especially if you want to do the tilt effect. I have it on my portfolio actually, although it's not a real depth of field, it's a more performant one. Just check tilt effect on Google or whatever. It's when you want to make things look smaller. You add the tilt effect and there is a focus on, I don't know, like a little guy, and everything around will be blurred. I mean, closer or further will be blurred, and it looks super funny. Anyway, we are going to add this depth of field effect. So first of all, we are going to import depth of field from React 3 post-processing. All right, make sure you're at the right place. It's from this one here, React 3 post-processing, depth of field. I'm going to save. Then we're going to comment the bloom. Bye-bye bloom, I'm going to miss you. Depth of field like that, and we auto-close it. So what do we get? At first, not much. We need to tweak it a little. Tweaks are a bit complicated. We need to set 3 main attributes that will help us. There is the focus distance. It's like I want to focus on my finger right here, and that something closer is blurred and something further is blurred. That's this distance here. Be careful, there's a catch. The focal length is the distance to travel from the focus distance before reaching the maximum blur. So see my finger right here. I want the focal length, this value here. If it's to be that value, let's say it's a rock value. So a rock value here will be fully blurred. Here will be not blurred at all. It will work the same, like closer to the camera, something like that. So we set that value. And finally, the bokeh scale, it's how blur it will be from that distance, how blur this part will be. Great. I don't even have to do drawings. So there's a catch, I told you earlier. Well, the thing is that the values are normalized space. Okay, it's in normalized space, meaning that it's from 0 to 1. So the value we have to provide for all of those values are 0 to 1. It's not absolute values like the distance from the camera to that sphere. It's going to be, I don't know, like something like 8. Maybe if you put 8, it's not going to work because it has to be between 0 and 1. 0 and 1, meaning the near and the far value. Actually, I'm going to do a quick drawing right now so that you understand what I'm talking about. We're going to put just values that look good, but I really need you to understand what's happening in there. Say that we have a camera right here. So the camera is going to be right here. Up, 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 up. And that's my camera. Okay, cool. We have our scene. Okay, it goes from there to there. We have our cube. I'm going to create a purple cube. Why not? So that's our cube. Up, 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 up. I'm going to add a quick perspective, cheap perspective, like that. Okay, your camera. Remember when we set a camera, we define a near and a far value. Okay, that's the near value. That goes, I don't know, from here to here. And I'm going to draw the far value with some orange. So it goes from here to, let's say, here. That thing here, what do we have as color left? This is the normalized value, okay? It's the part that goes from here, so the near, and the far. And it goes from 0 to 1. And that's the issue with the values that you need to provide to this effect. If we want our focus to be on the cube, we need to provide the value right here. Okay, and this value right here needs to be between 0 and 1. So you might need to do some calculations to get that exact values. It's a bit harder. Okay, I'm going to get back to the code right here and continue. So I'm just going to provide you good values. You can also just do that if you have troubles finding the right value. There are some methods that are a bit hidden, but there are some methods to convert from absolute values to normalized values. You can also do it on your own. Usually I just do it on your own because I retrieve the camera, I get the near, the far. You can ignore the near if it's quite a small value. And I just do some quick calculations to convert those absolute values to normalized values. Anyway, for now, because the lesson is big enough, I'm just going to put some good values. It's going to be 0.025 because the far is quite high. The far is going like super far away, so the scene is actually super close to the camera. Then the focus length, we're going to provide, let's see, 0.025, and the bokeh scale, I just tested values with the lever until I was happy with that. Will be something like that. And if you move, let's say you move the camera right here, you will see that the cube is a bit more blurred, especially like, yeah, give it maybe a smaller, put back the camera a little, and you see that this one is blurred. And if you move away, well, everything is blurred. So this can add a lot of realism to your scene, but I think it's not that great for performances, and the blur doesn't always look good. So it's up to you. Maybe give it a try, but maybe don't rely too much on it. I just wanted to show this one to you. Next one I want to show you is the screen space reflection, also called SSR effect. This one is really cool, but you can't always use it. You will see why. So the screen space reflection effect will add reflection to the scene at a decent frame rate. Okay, I'm just talking about a decent frame rate, meaning that for a good computer in a simple scene, it should be fine, but things get bad if you have a complex scene or if you have a bad computer. So you will see. Give it a try, see how it goes. It will try to calculate what should be reflected on the surface according to its position, its orientation, and the material properties. Meaning that if we want, let's say, to have a reflection on the floor, we apply the SSR effect to Effect Composer, and we change the properties of the floor so that it makes sense that it should reflect. You will see what are those properties that we need to change, and then it will try to the effect will check the pictures, check this fragment here, and see that, okay, there is something there that we should see there, because it will do some calculations, I will not go into details. I've already dive into the code. It's super cool. The technique is really great, but it will see that this sphere here should be visible there. And it will do that everywhere. At first, it doesn't look great, but with the right parameters, it will make sure that it looks okay and apply some jittering and some blur and check how far it can move forward to see if there is a reflection. I mean, it's super cool. Anyway, we are just going to implement it, and it's actually a good opportunity too, because we are going to have trouble making it work, and I'm going to show you how to make an effect or anything actually work when at first it doesn't look great. You will see. So first we're going to import it. So it's from this one, so SSR, like that. And then we're going to comment the depth of field, so this one here, and we're going to add the SSR, like that. And if you check that, it doesn't look good at all. Okay, what can we do to improve that? The best thing we can do here is to rely on working example. And that's exactly what I did. And that's exactly what I do when I'm discovering something and it's not working. I just check for examples to see how they made this thing work and look good. And it's exactly what we're going to do. On the React Free Fiber website, check here, we get, so that's the website. There is a demo page. So since it's in mobile, we can't see it, but in there is a demo page. So I've already provided you the link to the demo page. It's this one. Oh, 3GS Johnny. Lucky. And in there, it's just a bunch of cool examples for React Free Fiber that maybe you've already checked them. And what I like to do, if I want to implement something and it doesn't look good, I just check for an example doing it, and I will check that example. That's all. I would check the code, maybe take some part of that code to make it work for me. And if you search for SSR, see there, we have it there, we have it there, we have it there, etc., etc. So just check for those code. And we're going to use, I think it's this one. Let me check. I've put the code again. It's a code sandbox, so we can just check the code. See that? Yeah. This one seems to be working. Okay, we have the reflection on the floor and it seems to be working. I don't know why I can't rotate. I think by default we can't rotate. Oh, we need to click to make it rotate. Okay, why not? So we're going to use that example. I'm going to make it bigger so that we can see more clearly and give it a reload so that, yeah, the layout is a bit better. Let's go. Not this one, not this one. Yeah, actually, I need this part here. Also, be careful. If you click on the link, that example might be different, meaning that maybe React 3 Fiber updated, but if you remember, during the lesson, we are forcing a very specific version of React 3 Fiber, post-processing, etc. So maybe the example right here has been updated. Just be careful with that. You might have to do some tweaks to get the same result as me. The mesh standard material, yeah, check that. Just check the code. There is not too much code. As always with React 3 Fiber, it's usually quite simple. By the way, effects, see, it's in a separated component. We're going to talk about this one right after, but it's in the separated component, which makes more sense so that you separate the logic of your code. The plane is used on multiple elements, like this one, this one, this one, this one. So we need to check what's happening in there. The mesh standard material, if you check that, we have a roughness to 0 and a meltness to 0. So we need to set those to see a reflection. By default, just put the same parameter. Once it's working, maybe start tweaking them, but by default, just use the same parameter in order to make it work. So let's go. We're going to do that on the floor, which is the last mesh, I think. On the mesh standard material here, we're going to put the metalness to 0 and the roughness to 0. Okay, make sure to do that on the green yellow, the green yellow floor. You can do it on other objects, but for now we just focus on the reflection on the floor. Next, in the example, check there is leva, okay, so that we can tweak it, and that's great because we can have a different result. Yeah, I don't know if you can see in the video, but this is changing a lot according to what I do with those parameters. Those are the parameters used on the SSR. So what should we do? There is so many parameters. Should we add like max roughness to the SSR in our code? No, we just do the same thing. Okay, that's the point where I told you we're going to use leva. Let's just use leva so that we have something that is working. And anyway, this way we can tweak it. So we're going to open the terminal. I'm going to open a new terminal in the same folder and do npm install leva, and I'm going to use the 0.9 version, and you should do the same so that we are sure to use the same version. If you do that, you might get an error, and that's the same error as before. Maybe not. Just check on your terminal what you get. Me, I'm getting this error because there is a conflict. npm can't check if those dependencies are working together. I don't care. I just force it like that. Now we have leva in the project. I'm going to close that terminal, hide this terminal too, and I'm going to import. So for us it's inside experience, but you can create a effect component if you want. I'm going to import use control. Remember use controls, it will create those tweaks that we need from leva. Great. And I'm going to be super lazy, and you can do it like you have the example open on this side. I'm going to copy all of those, okay, the all use controls, the variable which currently is named props, everything. I just take it and I'm going to paste it right here in the experience. I have nothing but the return in the experience. I'm going to paste it here. I'm just going to do one change. Okay, make sure the indentation is right. I'm going to change the name here. I don't like props because we are in experience. Props of what? I want to use SSR props. Okay, it makes more sense for me. And if you do that and check your experience, you get this. And see, by the way, yeah, you might actually get a result. I forgot that if you give it a reload, you might see something, but anyway, it's not looking good. We need to tweak it a little. And we get the exact same leva configuration that we have in the example. And now we can use it. So we're going to use SSR props on the SSR tag right here. And we're going to spread the values. We're going to do something like that. And check that. Now it's working. And we can see the reflection on the cube. It looks quite good, actually. We're going to tweak it a little, but it looks quite good. Yeah, by the way, those parameters, if you tweak them, have a look to the performances. Changing those can have a drastic change, impact on performances and on the frame rate and how long it takes to render. So be careful with those parameters. Actually, no, we don't play with the actual floor, but if you want a floor looking a bit better, you can put, I don't know, some black maybe, something like that. Yeah, and now you get a nice looking reflection. Check that, it's looking so good. It's a bit weird because the this is white and we can't see much of a white because of how it works. I'm not going to go into details, but you can tweak your scene the way you want, and that's great. But be careful with performances about this one. Yeah, talking about performances, out of curiosity, let's activate all the passes together just to have a look. I think I'm going to close Leva. Let me check. No, we're going to comment it right after. If I'm, yeah, I think we are going to comment it anyway. So let's not close it by default. So yeah, out of curiosity, be careful if you're sensitive to flashes and fast movements. Maybe don't do it. But I'm going to uncomment all of them. It's going to look really bad, like that, and like that, just to check the performances. We need to give it a reload just to make sure. So we have everything running, even the SSR, which is bad for performances, and check there. It's okay. I'm still under 1 milliseconds to render my whole scene. 60 frames per second. I'm not putting it in a full resolution. I can do it actually. Check that. Okay, now it's full resolution, and I'm still below 1 millisecond. Sometimes it goes slightly up, but it's okay. Although I have so many effects applied, and that's great because our effects are being combined, optimized, etc. I just wanted to show you that it can really works well with this new post-processing solution. It looks bad, but you can add a bunch of effects and hope for good performances. Be careful, for your computer it might not work that great. I'm using quite a recent MacBook Pro, so it's okay. Test on your computer to see what you get, but anyway, it's much better than using the old post-processing solution. Nice. We're going to comment all effects. So this one I'm commenting separately so that we can activate them back easily. But we are not going to get back to those. You can comment everything or remove everything. We are done with those, and I'm going to comment the use controls too. Okay, this one, I'm just commenting like that. We get the basic scene because we are going to create our custom effect. Yay! Quite a big section, but a very interesting section. I wanted to add this to the lesson because it's a bit hard. I think it's a bit too hard to implement it. You will see why. So I wanted to show you how we do it so that you can create your own effects at some point. So we need to create the effect for post-processing and then make it available in React Fiber. That's the main issue with everything I'm going to show you right now. Since we are using React Fiber, it's kind of an abstraction on top of post-processing. If you want to create your own effects, you need to do it for post-processing and make it available in React Fiber. Okay, it's the kind of the hard part. Because post-processing is merging the effect together, which make the performances much better, into one shader, we need to follow very specific rules. All right, we are not going to write the shader for the post-processing like we did in the previous lessons. We need to follow very specific rules that I'm going to show you. We're going to create a drunk effect just for fun. That will make the screen wiggle. So it's going to do something like that. Okay, your whole image is going to do that, and it's going to be a bit green. And I got that from the Sea of Thieves game. I don't know if you know this game where you can drink booze, and when you drink booze, which actually there is no reason to drink booze, it's just for fun. Like you are sailing on your boat and you can drink booze, and your screen, if you drink too much, your screen starts to do something like that, and at some point you can even puke on your friends, etc. It's a mess. It's a mess. Bad jokes. Anyway, we are going to reproduce this effect because I think it's a good exercise. This effect is quite simple. I mean, the way we are going to do it is quite simple. We are not going to create a crazy effect, but just make it wiggle and look greenish. But it should cover most of the custom effects you would want to build. I've put some links, although we don't need those since I'm going to show how to do it like in the following part. But if you need to create your own effects, I've also put some links like custom effects right here. All right, this one is for post-processing, and this one is for React 3 post-processing. All right, it's two links since we need to do for both of them. I've put two links that explain how to do it. I'm actually doing it a bit differently from the way they propose to do it, because I think it makes a bit more sense, but the idea is the same. The result is exactly the same. So we're going to put, yeah, by the way, we're going to put the files in the src folder. So it's going to be right here. It's a bit messy. All right. Usually you put in separated folder, at least you put the, I don't know, maybe the shaders in another folder or all the custom effects in a different folder. So organize your code, please. Well, I'm going to put everything in there because we only have one effect and one component, the experience component. But for bigger project, I always spread into various folders, organize into various folders. So we're going to start by creating just a basic effect. We just want the effect to work, and you will see that it's quite a long process. So focus. The initial effect will do nothing so that we are sure that we have a base, and then we will add the effect on top of it. So let's go. First, we're going to create a new file. A lot of talking, let's start coding. And I'm going to call this one drunkeffect.js. In there, we're going to focus on creating the post-processing only effect. So it's going to look something like, yeah, we need to export a class. So export default class. We're going to name it drunk effect. When it's exporting by default, I like to name it just like I named the file. And in there, we're going to add a first method, which is going to be the constructor. All right, it's the one that is being called when we instantiate the class. By the way, there is a lesson dedicated to classes, modules, etc. It's the structure for bigger projects. If you're not familiar with what I'm writing right now, just check that lesson. Structure for bigger project. I'm quite sure that's the name, I hope. So we need to extend the effect class from post-processing. All right, post-processing, the dependency has an effect class. It's kind of a default template, and we want that class to extend this effect so that our class will have access to all the method and properties that are set by default on this template. So let's go. We're going to import, I think that's the next part. Yeah. Import effect from post-processing. I'm going to write it like that. And then I'm going to ask my class to extend effect. All right. Doing that, where we get, if we just do that, our drunk effect has everything that is available in the effect class. It's just extending and getting all the method and properties or whatever. And then I'm going to add custom code right here. So let's write a basic shader. Post-processing will take our shader and merge it with other effect shaders, as we said earlier. Our shader can be implemented in a function that must be named main image. I'm talking about GLSL right now. I'm talking about the shader that will do the effect we want to create. And we have to write it like that. It's not the usual, you know, when we write a shader, usually it's a void main, and in there we have to play with the GL frag color, etc. We can't do that the same way. We need to do that like this. So our fragment shader needs to look like that, because post-processing will then take that code and use it to combine it with other effects that are doing the same thing. All right, we need to do it like that, and we need to write it exactly like that. If you set a different parameter or you forget one in GLSL, it means it's a different function and it might break. So you need to write it exactly like that. And we're going to be a bit silly and put it right here. The shader is going to be quite simple. So in that case, it's okay to have it in the same file. So we're going to do const fragment shader equal, and I'm still going to use, you know, the GLSL command so that we have a syntax correlation. Syntax highlight, I think we say in English. Use back quotes so that, be careful, I'm opening it and closing it right here, so that we can write our shader on multiple lines. And in there, I'm going to write exactly that. So it's going to be void main image, like that, and I can add the curly brackets already. And in there, we need to write some weird stuff that we don't know yet. So by the way, I have the syntax highlight because I wrote this, and we saw that in a previous lessons. It's because I have what's the name? It's this one, the ES6 string HTML extension. So if you didn't do the lesson previously, I'm using VS Code. If you're using something else, you probably have something similar. But anyway, if you're using VS Code and you don't have the syntax, the colors on your code right here, you need to add this one here. I'm not going to spend too much time on it because we did it in a previous lesson. Const in vec4 input color. And right now you might think, what are those? Const, isn't it supposed to be like JavaScript thing? We're going to talk about what's happening in there a bit later. const in vec2, make sure you have the exact same thing as me, uv, and finally out vec2 output color. What are those? Damn, that's new. Yeah, I already told you that. So the parameters are slightly different than what we are used to writing in shaders. It looks a bit more complex, but there is a reason behind those new words. So I'm talking about this one here, and this one here. What's happening? We are using the WebGL2 syntax, all right? Most devices are running WebGL2, and we can use those new things that we have in WebGL2. It's adding information with each one of those parameters. So when main image, we are not going to call main image ourselves, but the post-processing library will do it. It will call that and it will send some parameters. So those are just parameters, and we are providing more information to those parameters. The const is for constant, and the parameter is not writable. We won't be able to change this one. In, so this one here, it's a copy of the actual variable, and changing it won't affect the initial variable sent when calling the function, meaning that if you want to change the input color, it won't affect the one that has been sent when calling that function, which we are not going to do. Out means that changing this value, so if we change the output color, the code that called the main image, it will change the actual variable that we send when we call main image. Like if we do something like A, B, C, this one here, we're going to change that variable here, and C will change. And C will be able, the developer will be able to use the new value that we inject, that we change in that function. All right, it's a lot to take. Don't worry, we don't really care about that. It just provides us more information on what they are supposed to do and how we are supposed to use them. As an example, input color, it contains the current color for that pixel, which is defined by the previous effect. Remember that we are adding effects. If you want to get the previous pixel, because this code will be executed for each pixel of the effect. So in there, we want to get that color back because we want to add our effect on top of what's already being drawn. And we can get the color using input color. UV contains the render coordinates. I think it's from 0 to 1, 1. I mean, 0 to 1 on X, 0 to 1 on Y. Maybe it's the opposite for the Y. Sometimes it changes. We don't really care, you will see a bit later. And output color is what we need to change in order to apply the effect. If we want everything to be red, in output color we do, I don't know, like R equal 1.0, G equal 0.0, and B equals 0.0, meaning we are sending just blue. And at the end, the effect will just be a uniform blue. That's the idea. Okay, so what are we going to do in there? Let's start very simple. Remember, we just want an effect that does nothing but still displays something. So it's not the drunk effect yet. We're going to output a vec4. It needs to be a vec4 because it's RGBA. It's going to be a vec4 where we just put the UV. Okay, 1.0, 1.0. We just put something. We could have tested with something else, like if you want something white, you just put that, but we won't be able to notice something. Maybe it's a bug, we don't know. If you want to put something red, you put something like that. And instead, we're going to send the UV so that we can see the coordinates of the fragment that is being drawn. And we put one like this. You will see how it looks, and it will ring a bell, I think. Okay, next, it's a lot of code. Okay, focus. Hang on. In the constructor, we're going to call super. What calling super does, it's calling the constructor, so the same method. In our case, we are calling super in the constructor, so it's going to call the constructor method on effect. Maybe the effect class is doing some stuff in the constructor, in its constructor method. Just in case, we are calling the constructor method of useEffect before doing our own stuff here. We just call super, and you can call super on other methods that we call the parent method, I mean the method on the parent, the same method on the parent class. By the way, if you call super in a function, it has to be the first instruction of the function. Okay, you can't do things like that. Write some code here and then call super. You need to call super as the first parameter. In there, we need to provide a few things. So in the super here, we need to provide a few things. it's three things. We need to provide the name of the effect. We can choose whatever we want, okay? Something like that. I'm going to change it right after. The fragment shader, we can take it from here. We could have written the fragment shader in there, but it would be a bit dirty, so I'm not doing that. We wrote it before and we send it right here. And at the end, we need to provide some options. And for now, we just send an empty object. Later, we're going to put a bunch of stuff right here. For the name, let's name it just like we named the class and the file. It's going to be drunk effect. I think it makes sense to put that. I'm going to add some line breaks because we're going to provide more things inside that object and it will be a bit messy at some point. So yeah, right here, it's a lot of line breaks, but it's easier to understand. Okay, we created a very simple post-processing, just post-processing effect. It should display just the UV coordinates once it's working. We are not importing anything, we just wrote that effect. Now we are going to write the React post-processing part. So let's go. We're going to create a new file. Where is my sidebar? Yeah, this one here. And I'm going to name it drunk. Don't worry, we won't have more files from now on. So drunk is going to implement drunk effect. And I'm talking about React 3-fiber stuff, meaning that we need to follow the classic React templates, etc. We need to create a component. So to create a component, we go back to the basics. We export default function drunk. All right, that's the way of creating a component in React. We are doing some React classic stuff. Next, to start with, I'm going to provide a mesh. Why a mesh? At the end, it's going to be an effect, but I just want to make sure that I'm writing this part right. My brain is already starting to melt. I need to do simple stuff, so baby steps. I'm just going to return a mesh and make sure that my component is working. We've been coding quite a lot without saying any result. I want to see if what I'm writing is working. So I'm just going to add a geometry, a box geometry like this, and the material, the default material, I'm fine with it. Next, in the experience, I'm going to organize them in this order: experience, drunk component, and the drunk effect. You organize however you want. I'm going to import that component, so import drunk from drunk.js. I like to add .js. And then I'm going to add it to the effect composer, just to see if it's working. Drunk, like that. Okay, I get the mesh. That was just the idea. I just wanted to add a mesh, making sure that my component is working. Now, back to the drunk component. We don't want a mesh. We want the effect. We're going to import that effect. Import drunk effect from, okay, it did it on its own. No, I want it to be written like that. .js. Okay, make sure you have the same as me. And I'm going to save. And I'm going to instantiate the effect like that. Effect equal new drunk effect. And I'm going to stop right there. Why? Because you might have an error. Okay, if you have an error, you did a mistake. I'm quite sure of it. But since we wrote quite a lot of code, we were not able to see where we did a mistake. So I'm going to show you my drunk effect.js. So check the experience. Okay, you had it properly. This one was supposed to work since we had a mesh right here. And in there, we imported the drunk effect that we wrote earlier. So this file here, and instantiated it in our drunk function. And right here, if you get an error, you probably did a mistake with the drunk effect.js. So I'm showing you my code right here. You should pause the video and see if you did something differently. That's all. That's the whole point. Make sure that you have the right curly brackets, you're coding super like this, etc. Just make sure you have the same thing. If you don't have an error, good job. Let's continue. Next in there, so in the drunk components, we don't want the mesh. We want to use that effect. So we instantiated the post-processing effect. We want to return it. And just like we did for when we're loading an object, we're going to use a primitive. So it's going to be primitive. It's not just to display some meshes, some models. It's also to kind of add those kind of things, classes, to our experience, to our JSX. So we're going to add object. It's also an object. Effect, like that. I'm going to auto-close it. I'm saving. And we get an error. Let me see. And I actually did a small mistake. So if you check my code, there is a small mistake right here. This one here should not be a vector2. So I wrote vector 2, it should be a vector 4. So I did a mistake and it probably followed me like, that's weird. So I give it a reload and we get this. Yeah, by the way, you probably need to reload. When we do changes in there, you need to reload. I'm quite sure of it every time we do in changes in this one. So yeah, this one here, output color, it was supposed to be a vec4, not a vec2. And now it's working. See, when I told you that doing any changes here, see, I'm giving it a reload. I did a small mistake. It's broken. So be careful with this, what you write in there. All right, so it's working. Congratulations, you have a very basic effect running right now, which is just displaying the UV coordinates in there, okay? And it looks like that because it goes from 0 to 1, from 0 to 1 on the X, 0 to 1 on the Y, and that's why here it's fully white. It's because we get 1, 1, 1, 1. Anyway, that's just like the UV, classic UV map. We're going to talk about props because see, in the experience, when we use the depth of field, the bloom, etc., we can set props, and we're going to do the same here. We're going to add some props to control our effect. We're going to do something quite simple to start with. At least we're going to be able to change the since it's doing some wriggle, we're going to be able to change the amplitude of the waves, so that it does like long one like this or very close waves. I can't do it, my arm doesn't have enough articulations, but you get the idea. And another one which will be how high the waves are. So if you want something more like this or something more like that, all right? The amplitude and the frequency, I think. Yeah, that's it, frequency and amplitude. And we're going to send those already like this. Frequency, let's put 2. Maybe it won't look good, but we're going to tweak them anyway. And amplitude, let's send 0.1. Okay, we will see what we get with those attributes. So right now, obviously, we're just sending attributes that we are not using yet. Then in our junk.js, just the component, we're going to retrieve those props. So props like this. And in there, you can maybe give it a little log like that to make sure that you get them. Okay, if you don't get those, check what you wrote here and make sure to save both files. And we are going to forward them to the drunk effect. Okay, when we do new drunk effect, we forward them to the drunk effect so that we can retrieve them right here. So right here, let's retrieve those props. Again, if you want to make sure that you wrote it perfectly, you can log them. By the way, as I told you earlier, logs at the end. So logs, I mean, after the super. Here, we give it a reload and we get those parameters. We are just forwarding those attributes to the drunk effect, like this, so that we can use them in here. This will be useful a bit later. For now, we are just sending the props. We can remove the console. Next, we want the developer, because we are not necessarily doing it just for us, and we also want to do it the right way, to be able to add a reference to this drunk effect. We didn't do it for the previous one, but don't do it, I just want to show you. We can do references, like if I do ref equal, and in there I create a reference, so right here, I can do that so that I can control the effect and maybe animate the effect on each frame or do something like that. Currently, this component, so I'm going to comment back the vignette. This component we've created here doesn't support reference. And we can do it. So we are going to import use ref. This part is totally optional, but I want to show you how to write a proper effect, the right React way, the right React Fiber way. So we're going to retrieve the use ref. And in there, we're going to create a reference just to test if it's working. So it's going to be the drunk ref equal use ref, like that. Next, we're going to associate it with our effect. So it's this one here. We're going to add ref equal drunk ref. All right. And what do we get? Give it a reload maybe. We get an error. Function components cannot be given ref. This is React warning us that, see that the way you wrote your component, it's a function component. You can't have a ref. Stop doing that. Or you should use forward ref, which will forward the reference. Yes, thank you. So that we can add a reference. We want a reference to that drunk effect at the end. So that's everything happening here. We can control it using that reference. That's the whole point. We are not going to use that. I just want you to show you how to do it in case you need that. So back to drunk.js. React told us that we should use forward ref. It's quite simple. Just be careful with the syntax. We're going to import it. So I will do it on the first line. Forward ref from React. Okay, just like that. This is a function. And check that we are just going to put our function drunk. So this whole code, check my screen, it's starting there and it's ending there. So at the end of after the ending curly bracket, the closing curly bracket, and it's starting there. We need to put all this code inside the forward ref, this one. So what I like to do in that case is cut it. See, I cut this part. Then I do forward ref, that function I've just imported. I add the opening and closing parentheses. Watch my screen, make sure to do it exactly like I do. And in there, I'm going to pass that function. Okay, so check my code right now. I have the forward ref. It's opening, I'm calling it right here. Opening parentheses, closing parentheses. I don't know how we say in singular. And I'm sending the whole function component I had in there. Okay. And don't save yet because we forgot something. The whole point was to create a reference. And in there, right here, so in the drunk function, in the arguments, we can retrieve the reference, which is actually the one we get from this one here that is being sent right here. And we are going to forward it. That's the whole point of forward ref. We're going to forward it to the primitive. So we're going to do ref, just like that. So check my code. I can give it a reload. The error is gone. Check my code. We are creating a ref right here. Okay. We are sending that ref to that drunk component right here. We are using forward ref from React to retrieve the ref here and forwarding the ref to the primitive, which is just a drunk effect instance. All right, that's the idea. In there, we saved an instance of the drunk effect. So if someone wants to play with it and animate it on each frame or whatever, change the uniforms and do stuff like that, they can access our drunk effect from this reference. It was a bit far-fetched, I know, but I think this one is super important, especially if you start creating effects that you want to share with the world. You can do it if you do it properly. Almost done. Check that. We are doing good progress. Getting back the render and make it look greenish, because that doesn't look like a good effect. That's not the drunk effect we are trying to create. We only have a UV coordinate. We need to fix that, and we're going to get it right now. Don't worry. So get back to the drunk effect right here. And to make it very simple, we're going to output the input color, just like that. We are outputting the same thing that we get. So what we get from the previous effect for us is just a render. And check that, give it a reload as always. We get back the scene. Right now, you have a good base. You have your effect running. Yes, the effect is running. We can start playing with everything. And we have props, we have ref, everything is working properly. We can start to have some fun. First, we're going to make it greenish, okay? Quite an easy one. With just like 3 lines of code, you will see it should look green. What we are going to do first is that we are going to save the input into a new variable that we name color. So input is a vec4, RGBA. We save it in a color variable. Why we do that? Because we can't change the input directly. It's a constant. We can't change the input. We want to play with that color. We first save it in a new variable so that we can have fun with this variable. And we send that variable to the output color. All right, it's just an extra step so that we can play with this variable here. Next, we're going to multiply the color by some green. So it's going to be multiply equal by a the color.rgb. Okay, we only multiply the RGB channels of the color. We don't care about the alpha channels. We just want to make the image look green. We don't care about the alpha. And we multiply it, so the RGB, it's a vec3. We multiply it by a vec3. that will be kind of green. So 0.8, 1.0, and 0.5. It's mostly green. There is some red too, and there is not much blue, and it will look, give it a reload, like that. Yay, you can start having fun. You can start tweaking the values, etc. Yeah, and then we assign it at the end. I think we already did that anyway. So that was the first part. We needed the color to be a bit green. I keep things quite simple now because it was quite a hard lesson. I'm just making the effect work. And later you'll be able to go further if you want. We want to make it wiggle. We want to make it wave like that. We need to mess with the UV coordinates. All right? Remember the UV coordinates? We need to mess with that. There is a UV parameter. You might think, okay, we need to play with this one. No, don't play with this one. This one are just coordinates that you can use to maybe apply. I don't know if we want the green to be stronger at the center, then we are going to use that coordinate. It's not to pick color on the texture. You can't do that. Actually, the one effect using the UV is the vignette. You know, it's making things darker on the sides, where it's using the UV coordinates to see if it's close to the center or not. So that's not the one we need to use. We don't need to know what is the UV coordinates. What we need to do is change that UV coordinate. And to change that UV coordinate, just like we did for the main image, we need to implement a main UV function. And post-processing will use that main UV function to get the coordinates, the UV coordinates, and in there we're going to change those UV coordinates. Instead of being something from 0 to 1 and from 0 to 1 on the vertical axis, we're going to mess with it and make it distort like this. So let's go. We're going to implement it. I can add it before. It doesn't matter. You can add it after if you want, but I think it makes more sense to add it before, since they are being called in this order. First the main UV, then the main image. And in there, we're going to add a in, out, a new one. Vec2 UV, like that. In, out means we can both read and write it. So why not? It makes sense. In, out. I think it makes everything a bit more complicated. As a beginner, you're like, what are those new things to retain? And but it's also prevent developers from making mistakes. And I think it also optimize how the GPU will handle those. I'm not sure of that, but anyway, more stuff. Yay! And in there, we're going to do a classic sinus. So we're going to play with the Y, making, by that I mean that the UV should go, see my cursor here, this part should go down, and this part should go down but less, and this part should go up. So we are making the change only on the Y axis. We want things to go up or down, and we want them to go up and down, so UV.Y. We are offsetting the, compared to the initial value, so plus equal, and we are going to use a sinus on it, okay? And the value of the sinus is going to be uv.x, meaning that x is doing 0, 1. And if you apply a sinus on the x, you get, actually I can show you, check that. Sinus x, you get this, all right? You can use Google to preview some, I do that a lot, to preview some formulas. That's not the best way of previewing formulas and functions, but I like to do this one because it's super handy. And see, the x is doing 0, 1, 2, 3, 4. And in result of doing sinus x, you get something that goes from 0 to 1, back to -1, back to 1, back to -1. It does something like that. That's a classic sinus. You probably already understand this one. And we can test it, give it a reload, and we get that. So it's working, but the effect is way too strong. It doesn't look really good. Later, we're going to use the props. So those props right here, but for now we're going to use a default value just to make sure that it's working. So UVX is doing from 0 to 1. We need the frequency to be higher, so we're going to multiply by 10.0. It will look like this. So the frequency is higher, great, but the intensity of it is way too strong. Remember what I just shown you, it varies from -1 to +1, meaning that our UV is going +1, -1, +1. It's much higher than our screen, so it doesn't make sense. We need to lower it. I'm going to multiply by 0.1 and check that. Now it's working. And see, you can still rotate around. You just messed up with the UV and everything is still working. You can zoom in, zoom out, and you will start to puke in a few minutes. Let's use the attributes. So we put 10 and 1.0, but we want to use those attributes right here. We are almost done. Now is the easy part. You're fine. It's okay. The melting brain time is over. So in drunk effect, we sent the props there. Remember, you can give it a little console log if you want to check them. It's right here. We have the frequency and the amplitude. Nice. How do we send those to our shader? First, we can destructure it. Let's do it. Why not? Frequency, amplitude, like that. And if you want to log them, obviously it's not props anymore. It's frequency and amplitude. So we get 2 and 0.1. Next, we need to send uniforms. Right, you remember that from the shaders, the shader chapter. We need to send uniform to use them here, and it works the same way. No surprise with this one. First, although we are going to see some cool new features actually, but the shader parts work the same. We need to send a uniform, and then we retrieve it here, and we use it in there. So the format is different than what we are used to, and we need to create a map. Remember when we wanted to send uniforms, it was an object, and in that object we were sending properties for each uniform, and in there we were sending an object with a value property. It was a bit messy, but it was working. In there they decided to go for a map. What's a map? I'm not talking about the map method that we use to, to loop on an array. I'm talking about this map here, and I've put the link as always. It's for MDN. A map is a mix between, the layout is a bit weird. The map is a mix between an array, meaning that you can add some items to the map, and an object on how to retrieve those. It makes sense. In that case, I would just show you how to use it, and it should make sense. If you want to check the map, just check on MDN. You have some examples. You can add elements to it. You can delete them. I mean, it's quite simple actually. So let's go. We want to create a map. Remember that object I told you earlier that we need to add the object, and we're going to add a bunch of stuff in there. We're going to send the uniforms in there. So uniforms, and in here we're going to instantiate a map. So that's kind of weird array object thingy. To the map we can already send initial values by sending an array to it. That's one way of setting a map. And in there, so be careful. I have an object, an array opening and closing inside the map instantiation. And in there, we need to provide another array for each value we want to put in that map. We have the frequency and the amplitude. So we're going to provide the frequency here. The first item of that object is the name of the property, although it's not really a property. And the value, we can provide the usual object with a value property, which is going to take the value from the frequency right here. And we can actually remove that console log. All right, it's maybe a bit new, but that's just syntax. Check my code, it's just syntax. There is an array inside an array. The first parameter is the name of the property. I'm not sure we talk about properties, but let's say property. And the second value of that array is the value associated with that property that will be inside the map. And we can do it for the frequency, and we can do it for the amplitude like that. Okay, just save, give it a reload just to make sure that you didn't do some syntax errors. It seems fine. We can continue. By the way, yeah, I wanted to show you that new thing from 3. I don't know when they added that. I'm quite sure initially we didn't have this, but I think it makes sense, so we're going to use it, and I wanted to show it to you. The way we create a uniform, we write an object with a value property, just like that. It's working. We can use that, but I wanted to show you that now we can do something like this. Import uniform from 3. We could have don't do it, but the usual, all as 3 from 3. We can still do that and then use 3.uniform like that. But I wanted to show you, so this one is the kind of the usual thing that we do in this course, but you can also import specific classes, and we're going to do that this time. Why not? We're going to import uniform from 3. And in there, instead of creating an object, and we don't know what's that object about, we can do new uniform frequency, just like that. maybe it's better, maybe you like it more, I don't know. I think it makes sense because right now we know that we are creating a uniform. It will result in almost the same thing. All right, there is no extra bonus by doing that, but I think it makes no sense. We immediately understand that it's a uniform, and internally 3GS handles it. I think it makes more sense like for cloning some classes, etc. Some very specific method that we don't really need. So it's up to you. I like to use this one now because it makes more sense. Someone that checked my code knows that I'm sending a uniform to this. Okay. So we sent two uniforms, the frequency and the amplitude. I didn't wrote it, like U amplitude. I wrote it just frequency and amplitude. You do whatever you want. And in there, at the beginning, we're going to import those, retrieve those the usual way. So uniform, it's a float frequency. Remember that from the shaders. Uniform float amplitude. So if you wrote U amplitude, you have to write U amplitude. So I'm just writing amplitude. And we can use them. So frequency, we will use it right here. And amplitude, I will use it right here, like that. I'm going to save, give it a reload, and now it's working. It looks a bit different because we are using those values here. And if I put, I don't know, like frequency 20, it's working. By the way, you seen what happened here? I gave it a reload, but you don't have to give it a reload anymore. Check that. I'm moving out. I have this, and I'm changing the value back to 2, and it worked without having to reload because now it's using the hot module replacement and the attributes. And since this is working, and we already have Leva installed, what if we finish? I'm not sure it's the end actually, but let's add the frequency and amplitude to Leva. It's going to be super handy. By the way, you should maybe do it on your own if you want to practice a little. This is classic Leva usage with a component and its attribute because we did everything right in there. So maybe you should try on your own. Anyway, let's do it together. So first, we already have use controls in there. It was for the SSR. So I'm going to put it, let's say, over there. I'm going to create drunk props. I'm not destructuring it, but you can do whatever you want. So use controls. I'm going to put it in a folder. I'm going to call that folder drunk effects. And I'm going to send an object with the two tweaks I want for this one, which are frequency. It's going to be a default value of 2, which is the same that we have right here. I'm going to put a minimum value and a maximum value so that we get, a slider. It's a bit more handy. And then I'm going to do the same for the amplitude. Let's be lazy and duplicate it. The default value is going to be 0.1. The minimum value is going to be 0. And the maximum value is going to be 1, which is already way too much, but let's put some values. And we get this. Nice, but changing those is not working because they are not associated with our effect, so we can associate it with our effect. The name is drunk props, and we can spread it right here by doing spread drunk props. And check that now. We can control it. Nice, and it's working. Cool. We are almost done. We need 2 more features. First, we didn't talk about the blending, and this effect is prone to use the blending properly. Using the blending on this one is not working yet, but the blending is the opportunity to control how the green color is applied on the rest of the scene. So if you want to provide that drunk effect to other developers, it's cool if you let them choose the perfect blending for their project. So let's do that. In the fragment shader, we are going to send just a green color. Follow me on that. So in there, right here, we are just going to, it's going to be weird, but follow me. We are going to just output a green color. So vec4, I'm going to set it to 0.8, 1.0, and 0.5. I think it's the same, but it's a vec4. So we also need, the output color is a vec4. So we also need to provide the alpha channel. You can provide just 1.0, it should be fine, but let's preserve the alpha that we had from the previous color, the previous effects. So we're going to use input color.a, like that. If you test that, give it a reload, it's all green. Why? Well, because we are just outputting green. Where is this going? Well, here's the thing. We're going to change the blending so that this green will be applied differently. It will be maybe multiplied, or maybe it's going to be a soft light or a screen blending, and the developer will be able to use how that green color blends with the scene. So back to experience. If we try to set the blending, we do blend function. Oh, sorry, be careful. A blend function like this. And then we provide, let's say, a blend function that should look pretty good. It's the darken. Okay, I'm going to save and check that we get the same result. Why? Well, because we are not using that in our code. So let's move forward. We're going to go into the drunk effect, because remember that we are forwarding every props. See those props? We're forwarding everything from the component to the actual drunk effect class. So in there, we get access to those props, and we're going to retrieve the blend function. If you want to make sure that you wrote everything properly, you can log it. And we get 6, which is the darken blending. Great. We can remove the console log and move forward. And we're going simply to forward it in there to the options of the effect. Just like we sent a uniform, we can send a blend function, not inside the uniforms. Okay, it's another property of this object here. So blend function, just like that. Give it a reload, and it's back. Even though we are sending just a green, that color, that green color, will be blended with what was there before, which is just the render of our scene in our case, and it's working, and it's using the darken function, which looks like this. And if you want to test another one, you can, I don't know, try the screen, which is way too much. Maybe the multiply. I don't know if this one is looking good. Yeah, the multiply is looking good too, but I like the darken. I think it looks pretty cool. By the way, when you send something that, and the name is exactly the same as the property, you can just do it like that. Okay, it's just a JavaScript. You do whatever you want. I'm not a big fan of this one, but let's use it. I know that a lot of developers like to write it this way. But there's an issue. Imagine that you create that drunk effect, you're proud of it, you are sending it to other developers, and other developers are like, your effect is not working really well because I get just a green screen. What's happening? It's because the other developers are probably doing something like that first, okay? They are just trying to implement it, and it looks at that because they don't provide a blend function, a default blend function that will make it look good. So we need to fix that, and we're going to fix that quite easily. We're going to set the default blend function to darken, so that by default, without adding the blend function or anything else, it will look good. To do that, it's quite easy. In a drunk effect, in there, we're going to import. Oh, sorry, it's from the post-processing, so we already have it. It's going to be there. We're going to import blend function. It's the blend functions. Okay, it's the same import that we did. It was there, so the blend functions there. Okay, it's the same import from post-processing. It's the list of blend functions. And we are going to set a default value, and to set a default value, maybe you already know, in there we want a default value on the blend function. We can do equal blend function, and we're going to set it to darken because I really like this darken. You give it a reload, it's working, and now when you instantiate the drunk effect by just putting drunk effect like that, check that, it's working. All right, give it a reload, but it's working. The other developers can just add the effect and see a good result. That's nice. And I'm going to put it back like this so that we have a clean code with everything set properly. And the tweaks working. See, we are almost done. We are just having some fun. Let's make our effect worst. I want the player to puke at some point if he drinks too much booze. So we're going to animate it. I mean, it's already quite hard to see. See, if you start moving around, feels bad, which is actually what we want to, it's the effect we want to create, but we're going to animate it so that it's even worse. And that's a very interesting part. A lot of effect needs to be animated. See the noise effect? The noise effect is actually animated because the noise changes. So let's do that. First, we're going to send an offset, okay? So that the scene right here is going to move just like that. It's just a classic movement. If you put scene.x, check what we get here. So this one is doing that. See, the 0 is right here. If I put plus 0.1 is going to be slightly offsetted. If I put more, because you can probably not see much, see it's moving like this. So just by adding or subtracting to the x inside the sinus, we are moving the whole sinus. Great, that's what we are going to do right now. Up like this. So we're going to use a uniform. Back to drunk effect, we're going to send an offset uniform in there. We could have sent just the time. All right, it's totally doable, but I want to do things a bit differently so that we practice more stuff. So we duplicate the amplitude. I'm going to send an offset. Make sure that you have the right commas at the right places. And in there, I'm just going to send a uniform to 0, just like that. Okay, if I give it a reload, no changes. We are just sending a uniform that we are not using. Then, back to our shader, we're going to retrieve that uniform. And it's the offset uniform. And as I told you earlier, all we need to do is add it inside the scene, right here. Maybe you want to do it on that one, and in that case, you need to add parentheses. It's details. You do whatever you want about that. I'm just going to add it inside the scene. And finally, how do we update it? So it's already spoiled right here, but you might think that you need to use maybe use frame. Would make sense, but this effect right here, it's not a React 3 fiber thing. It's a post-processing effect. And we are going to just do the post-processing style, okay? And it's super easy because if you add, see, there is a constructor method right here. If you add an update method, that update method will be called on each frame automatically. Check that. I'm doing an update, I'm giving a reload, and that's it. This function is being called on each frame. Great. In there, we can have fun with our uniforms. So let's go, let's do that. We're going to play with the uniforms, and we can access the uniforms. I'm going to put it inside the log. I'm going to do this.uniforms, and check that. We get access to the uniforms. Be careful, it's on each frame. Not great for performances. Your console log is being filled with that object. I said that object, but remember, uniforms is a map. Okay, uniform is a map, so it's a bit different. It's not just an object. I told you it's kind of a mix between arrays and object. I really liked map, but I tend not to use it because I think it's a bit more complicated for beginners. So that's why I'm not using map. But how do we play with the offset value inside the map? So we already know how to access the uniforms, all of them. It's a map. To get access to one specific value in the map, you need to use the name here. You need to do get offset, and this will return this value here. Okay, and this value here, since we use a uniform, it will create an object with a value property. So it's going to be offset.value, and we're going to do plus equal 0.02, like that. Give it a reload, and now it's moving just like waves on the sea, and that's where you start to get sick. Okay, I make the frequency higher. I've set a low frequency on purpose so that you can still focus and not get sick just by watching the video and your effect. But if you want to make it worse, just add more to this one, and you start to get sick quite fast. Nice. We made a classic mistake, by the way, and didn't take care of the frame rate into account. Okay, we forgot that this will result in different speed of the effect depending on the frequency of your device. Okay, I have a device that is running at 60 frames per second. If you have, I don't know, some PC game device, the effect should be faster. So we're going to take that into account by retrieving the delta time that we can retrieve right here, okay, in the parameters. There are two first parameters that we're going to set in order to get access to the third one, the data time, and those are the renderer. Yes, it's the actual 3JS renderer. The input buffer, I'm not going to talk about this one, and the delta time. All we need is the delta time, and I can log it out of curiosity. It looks like that. Those are in seconds. So I'm going to take it from here, and instead of adding 0.02, I'm just going to add the delta time. And I give it a reload, and it's working. It looks the same for me because it's almost the same value, but for you it might be a bit different. I mean, you should get the same animation as me. That's the whole point of using the delta time. I'm not going to go into details because we've done that so many times. And we are done. What a lesson. But that was so cool. We discovered so great effects. We can add so much to the experiences we are creating, and with good performances. I mean, the bloom, it's so great for the result, the experience, and the performances are so great that we should just add on every WebGL experiences, isn't it? So still, you can go further. I had to stop the lesson at some point, but you can go further. First, feel free to explore the various effects and test further. We just tested maybe 5-6 effects and created one ourselves, but there is a lot more, so check those. I already gave you the links. Next, you can improve this one. Initially, I wanted to add much more, but it was already quite big, but you can have some fun. First, you can control the color. That one would be great, like a tweak, a prop, to be able to change the color that you need to send as uniform, and then you add it to Leva so that the developer can choose whatever color he wants for this effect, because right now I just put some green stuff right here. That's a bit sad. Next, you can add attributes to control the animation speed. Currently, we are just using the delta time on the animation speed. Maybe you can do something else. And further proposition, add a debug UI to control those attributes, so the delta time and the color, and you can add much more, maybe improve the distortion. I don't know, it's your ideas, do whatever you want, and I will see you in the next lesson.